Example number 1, solve the system y equals 1/3 x squared minus 3 and x plus y equals -3. Now yesterday when you solved this system you did it graphically. So what you would have done is you would have graphed this line. Okay, this is a line because the exponent is the implied 1. Okay, it's linear, not quadratic. And this parabola. How do we know it's a parabola? Because we have this squared term on the x. What I've done is I've given these two things numbers, because what we're going to do is we're going to take one of them and substitute it into another. We look at this first one and we're like, ah, this is a gift from the mathematical gods, because we have a term y isolated already. So if y equals 1/3 x squared minus 3, what I can do is whenever I see a y, I can just write this instead. Remember, if we have one equation and one unknown, we can actually solve for that unknown. But if we have two unknowns and one equation, we can't really solve for it. Now remember exactly what we're doing graphically. We're finding where these two things intersect. So wherever I see a y, so I'm going to just substitute 1 into 2. And I'm going to find a better marker because this one really stinks. Found it! So I'm going to say x plus, I'm not going to say y, I'm going to say plus, and I'm going to put it in brackets because it contains it really nice. 1/3 x squared minus 3 equals, so I've written down what my y term is, equals minus 3. Now I'm going to let those brackets free. X plus 1/3 x squared minus 3 equals -3. These are kind of not as important because this is not a negative and we're not multiplying in anything. But if the y would have a coefficient, especially if it's negative, it's really important to keep those things in brackets. Now what I want to do is I want to make sure that everything's off to one side, so I'm going to add 3 to both sides here, and I'm going to change the order a little bit so it looks more like a general form quadratic equation. 1/3 x squared plus x, -3 plus 3 is 0, so we're going to get no constant term, equals 0. Alright, so let's pause and think about this. We're going to find out how many points. Just for the record, I did not pick my nose and look at it like this. I scratched my nose, and when I looked on my hand, I'm like, oh no, did I get marker all over my face? Just for the record, I did not pick my nose and look creepily at it. We're actually going to be solving for. Remember, there could be 0, there could be 1, or there could be 2. What's going to be helpful with that? At this point we can use the discriminant. Once we've substituted one equation into another, what we want to do is we want to use the discriminant to see how many solutions we're actually solving for. So 1 squared, y1, because there's a 1 here. This is our b term, minus 4 times a, which is our a, 1/3, times c. What's our c? It's just 0. Times 0. Equals, well, it's just 1. Know that 1 is greater than 0. So how many solutions is this going to have? It's going to have 2 solutions. So it's going to look it's good. I'm just writing I'm just drawing a quick sketch. But it's the type of thing where we have 2 intersections. So we are going to have 2 x terms and we're going to have 2 y terms. So let's go back to this one. Maybe I should just make a note here. 2 solutions. So what I'm looking for here is I'm just gonna take an x out of each of these terms, actually 1/3 x. So I'm left with x plus 3 equals 0. I have two x values that I need to substitute for. X equals 0. Why x equals 0? Because of this. There's an x hanging out front. And this one right here, x equals -3. Now, what I'm going to do is I'm just going to take these x values and I'm going to substitute them into one of these equations. So I'm considering both of these equations here, and I'm thinking one is going to be easiest. Why? Because it says y equals. So whenever we are given an x point and we want to find out what y equals, this one's set up right for it. This one we have to do some fancy footwork. We have to subtract x from both sides. But this one, it's just straight up y equals. So I'm just going to substitute my x value for my two different x values, and I'll put it in here. So I'm just going to say sub in 1. It doesn't matter which one you use. You can use both of them, but it's smarter use of my time to sub it in 1. Y equals 1/3 times 0 squared minus 3. Y equals -3. Since we're looking for a point, remember we're looking for the x and y value. So the coordinate that that one of the solutions is at 0, -3. I'm going to substitute -3 into number 1 again. So y equals 1/3 -3 squared minus 3. Y equals 1/3 times 9 minus 3. Y equals 3 minus 3. Y equals 0. So the coordinates of my second solution is just my x value, -3, comma, my y value, 0. So let's just recap. This is what I did. I substituted one of them into another. I substituted 1 into 2. At this point, I thought, okay, I need to be secure in how many solutions I'm going to be getting out of this equation. I did the discriminant. I figured out that it was greater than 0, so I know I'm going to have 2 solutions. So then what I did here is I factored it. That was the easiest way to solve this equation. Then I substituted in whichever one is easier. So I know that I have 2 solutions with here, x equals 0 and x equals -3. When I plunk it into number 1, I figure out that we have the x coordinate when x equals 0, y equals -3, and when x equals -3, y equals 0. So those are the 2 coordinates of the 2 points of intersection.